Hello and good morning. Welcome to the panelists and welcome to our third and last day of our festival. Thank you very much for having come so early, and I would like to tell you what we have in store for you. This will be about the notion, which is very important for the notion of artificial intelligence, which is the driver of it all, namely intelligence and stupidity. So the first panel will discuss what is artificial intelligence, and in the panel at 1 p.m. it will be about artificial stupidity. So the first panel, shouldn't we mention several kinds of intelligence: social, biological, technical, artistic intelligence. So how can you distinguish human and machine intelligence? And in the second panel about accidents to do with artificial intelligence. If artificial intelligence is stupid, well, is that also to do with the people programming it when artificial intelligence is stupid? Yesterday we heard the question, why are people so daft and develop computers who can play chess better than human beings in order to rob oneself of such a nice leisure time activity? So to develop artificial intelligence it's more important to develop artificial intelligence which enhances human enjoyment. So this afternoon we will have a panel with Moritz Ingwersen and with other panelists, Robert Gairos, for instance, and we will hear about accidents and deception to do with artificial intelligence. And at 3:30 we will wrap up the festival. We will come full circle, and the Goethe-Institut, our partner, will participate. This will be related to the keynote speech of the first day, where Toby Walsh took us on a journey into the year 2062, wondering what life will be like, whether I will experience, well, if I'm lucky, maybe I will. Generation A is algorithm. That was a project of Goethe-Institut, and we will hear from them what they expect of artificial intelligence, what the questions are, the important issues, and they will talk about that during our concluding panel at 2:30. It will be conducted in English, and for all those who would like to listen to a German translation, at 2:30 p.m. You can help yourselves to a receiver and headset, where our two interpreters are sitting in their booths, and they have already translated the whole conference. And with those receivers and headsets, you can listen to a German translation. With that, it's over to Blanka Weber. Moderare means connecting. And welcome everybody. 10 minutes ago we were wondering who will find their way here this early in the morning, but the hall is jam-packed. There is a groove in the air. Over the next 60 and 70 minutes we would like to talk about intelligence. When you arrive here, when you are a participant in this festival, some may not be well versed with this topic, but there are also experts in this room. At the library, you will have seen two cute robots, Gaia and Naomi, or you may have had a perfume created based on AI. You may have had expectations, may have been skeptical, may have strolled through the exhibition. And you may know this issue has good sides, but also aspects which we should be critical about. So there are pros and cons. And there is the big question, what is artificial intelligence? Ethical, social, technical, and lots of kinds of intelligence we can shed light on. So what is the impact on learning for all groups of people, on our activities for us as human beings, and what does that mean? Consciousness, human beings, machine, and the environment. We would like to talk about that with a sociologist, an IT professional, and a researcher who is an expert in learning and teaching and knows a lot about feedback strategies. I would like to start with the sociologist's point of view, Professor Dirk Baecker. In our bookstore, there is a book with the title Intelligence, Artificial and Complex. You teach at the University of Witten, Herdecke, at the economics faculty. You are a sociologist, and you have a look at artificial intelligence. What is that? What does it mean for us? How do we deal with that? Our first question for you, a definition of artificial intelligence. I know we could go on until 5 p.m., but basically to set us in the mood. First, I have to mention some disappointments. When you talk to the engineers of machine learning, if they are not in front of a TV camera, they reject the notion of artificial intelligence. This was coined in the 1960s and 70s of the last century, when the idea was that based on computer programs, systems of symbols, so systems which can calculate using certain operators in order to perform logical calculations which can mirror human intelligence, that failed and led to a winter of AI. Under the label of artificial intelligence, we now understand something different, namely statistics. What is important for me, what about this comparison between human and artificial intelligence? And there is some disappointment as well, namely, no human being knows what that is. Human intelligence. We've got a mental intelligence, our consciousness. We have a neural intelligence of our brain. We have an organic or even immune system intelligence. And last but not least, social intelligence, with which we can stay synchronized. This is the phenomenon I'm most interested in. But intelligence as such, well, you have to distinguish between those fields. So my slogan is we shouldn't just count to one, so society. IT experts shouldn't just count to a computer, but human beings, brain, the organism, the machine has to be seen as a constellation, and we are not used to that. Our learning researcher, what do you say? Do you say there is no human intelligence? There are different kinds. Professor Susanne Narciss, you are at the Technical University of Dresden. You teach the psychology of learning and teaching. You look into design and evolution and also feedback strategies, and will know what does it mean, human-machine interaction, and how would you define human intelligence? Answer: a lot has been said about artificial intelligence, historical aspects, disappointments, and with the label AI, anything is comprised where data-driven algorithms recognize a structure, and that supports decision-making processes or make decisions in the first place. There was the thesis, we don't really know what human intelligence is. We also heard it can comprise lots of different fields. What I can contribute is the following. Psychologists, since the beginning of the 20th century, have looked into the construct of intelligence. I call it a construct in order to make it clear that it is not something we can observe. We can only draw conclusions. It was developed in order to develop test processes, in order to select people for certain professions so that you find the right people with the right skills. In psychology, this construct of intelligence is a notion which denotes mental skills in lots of fields. Mental intelligence has been mentioned, so mental skills, mathematics, the natural sciences, artistic skills, spatial, visual aspects come into play. If you do an intelligence test, you find a broad spectrum of tasks, but they are relatively isolated, and the question still is, what about other fields like body intelligence, social and emotional intelligence? There are approaches which try to comprise that as well. When we say intelligence is the construct to understand mental skills, should we put the other aspects under that notion as well? What is an important notion in teaching research is the notion of competence. Competence is about knowledge on the one hand, but also skills, then motivation, values and attitudes, which yield a whole. Competence is important in order to come up to specific requirements in special tasks to cope with complicated decisions. This is what our politicians do during the pandemic. But the responsibility component is then usually delegated to specialists because they don't want to make this decision, or in other situations which are highly complex, and our world today is highly complex, we have to look at the whole interplay of mental skills and other skills. Competence, well, that is a good cue, but what about human intelligence? If we yield a lot to machines because it has become so easy. Tim Landgraf, you are a professor of artificial and collective intelligence. You teach at the FU Berlin. You are interested in guppies, in millionfish, and bees. Guppies are brightly colored, glossy fish in your aquarium. So you are interested in artificial intelligence and robot-animal interfaces. So you are at the interface of artificial intelligence, robotics, and human intelligence. Can you tell us more what your work is all about? Answer. Intelligence, for me, cannot be clearly defined. Engineers cannot do it. We don't need it as engineers. Two very fitting approaches you have mentioned. Well, for engineers, it doesn't really matter. We have a task which needs to be solved. Whether you call it intelligent or stupid is not really relevant for us. So, as far as intelligence is concerned, what we do in our group, well, the main question is not whether individuals can produce intelligent behavior, whether it's an animal with a brain or a robot fitted with a program, but how the group is intelligent, how the group can produce intelligent behavior without some central control. So somebody telling all individuals, do this, but what we see in swarms, but also among people, among human beings, namely individual behavior, interactions with each other, the observations of those interactions, the dynamics of all interactions, whether that leads to group decisions during elections, for instance, or our decision in the supermarket to go for this and not that yogurt. This is not based on your own decision. The history of all our interactions with others has led to this decision. So it's a different level where I look into intelligence, but as every group behavior is comprised and is the result of individual behaviors, we need to understand those as well. We mainly have a look at simpler organisms, honeybees and guppies, and not human beings, because they are very complex and it's hard to measure. About chess, everything has to be seen in a model, and chess is a good model for one kind of task of planning intelligence. When we have solved the problem and where we can solve relevant problems, our problem is the intelligence of the group, the bee or the guppy. But it's not just about bees and guppies, but about human beings as well. Human beings are fascinated when they look at animals and we discover systems, for instance, a precise anthill, really well built, or a bird putting the nut where there is a high likelihood that a car will run over it and the bird can crack the nut, or squirrels finding food, and you are interested in bees and this kind of fish, bees and guppies. Why those two? Why are you so fascinated by bees and guppies? Well, why am I doing it? I don't really know, but it's enough for me. If somebody pays me for doing something good, well, I don't question that. That is a very weak argument, Mr. Landgraf. Of course, I'm interested in the behavior and decision-making processes of groups. Well, let's eat out. It's not clear where we go. You have to exchange information about where to go, where to find a good restaurant. If we could have the same discussion and I replace one person, will the result be the same? Not necessarily. So it's not linear. Small changes may have a big impact, but how does it work? How can you moderate this process? How can you moderate what is going on during an exchange of information? Human beings are highly complex, so I don't even want to start. For guppies, that's a well-established model. They do everything. So everything to do with group behavior is a group movement. So it's not about elections and making a choice in a supermarket, but they swim either left or right. So we will come back to that later. Ms. Narciss, when you look at animals or tests like that, experiments like that, and participate in that as well, what does it mean for learning and teaching strategies? Because usually we are in a transformation society where education has become a valuable asset, but the question is, when becomes life too easy for us? When do we do without the feeling of success about having learned a language, or third, fourth, fifth language? So, new learning strategies. What about that?
I wouldn't really see the last question in relation to the things we've heard so far. First of all, I would like to follow up on what you said. Everything that we as human beings learn from the behavior of animals can be put to use. Let me give you an example. The movement of ants are used in order to optimize traffic and the movement of cars, because we can identify different principles that we would not have really found out about otherwise. But when you said getting information within seconds and then delegate that to the tech department. And when you mention that, I'm thinking about the fact that the more I hand over to the machine, the fewer my opportunities are in order to get better and improve my abilities and skills. I assume that you all are well aware of how it feels when you stop doing certain things in terms of sports, cognitive tasks, music, education, etc. Usually our learning performance is increasing, but in order to achieve that, we need to train frequently and regularly. You know that once you stop using your abilities, then the learning curve decreases and plummets. And then you will stop improving and your skills remain on the same level. So the more you hand over these tasks, the fewer your opportunities for improving yourself. So that again changes the potential of your behavior, and I need to improve or to regularly practice in order to be able to develop further. If we're talking about areas in which we are human beings are important and have to perform different tasks, for example, in terms of areas relating to Industry 4.0, we have already transferred different tasks to machines. And in my opinion, a lot of effort goes into it. You cannot build in as many sensors into a car to make sure that you as a human being do not have to pay any attention anymore. Engineers tell us that 100% of automation in terms of self-driving cars, for example, is not possible. So they always need to factor in the human being and their abilities. However, we have great interconnectedness, individual dynamics, but we need to develop an understanding of what is happening. And if you bear in mind that you are not frequently involved in the proceedings, then this is becoming more and more difficult. So we as human beings need to find the perfect balance in terms of developing machines while considering that human beings are still part of the equation. I am part of the Center of Tactile Internet with Humans in the Loop, and Humans in the Loop is the key point. Human beings need to be part of the system, and when it comes to that, psychologists are important. We have an interface here between engineering technologies and psychologists in order to find out how, for example, mobile agricultural machines always factor in the human being so that human beings feel that they are needed, can train their abilities, and are at the same time supported by the machine. So as you can see, this is very complex. I would love to know about the sociologist's point of view on that, but I'm also interested in knowing what our audience would like to ask. That also goes out to our virtual audience, because we would love to exchange our opinions with you and what you think. For example, to which extent human beings need to be factored in. So please raise your hands if you have any questions, and once the light is switched on, I know that there are questions from our virtual audience. First of all, Mr. Becker, Ms. Narciss just raised the aspect of having a learning effect, or rather of learning not improving if we hand over too many tasks to machines. So what is your opinion as a sociologist when it comes to learning behavior? I think I am concerned about it, but I'm also not too concerned, because we have so many different fields of competences, and there are so many areas in which machines can support us, that the question of whether the human remains within the loop is a question we need to ask ourselves over and over again. My chair deals with observing digitalization projects in SMEs, not in the large corporations, but rather small and medium-sized companies. And we really observe the interaction between the managing directors and the workers. Also, when it comes to the machines they use AI to a limited extent, and we observe what can be achieved by means of the machines and to which extent they can support them when it comes to the experience of the workers. Some of the managing directors are shocked when they learn how much their workers actually need to know about the machines to keep them running. Because we usually tend to think that a machine is built in order to work smoothly for the rest of its life, but we know that there is no machine. Of course, there are always exceptions to the rule, but that most machines really need maintenance, for example, because they run too hard, because of wear and tear, because any other thing could go wrong. So the interaction between humans and machines is a major aspect for these small and medium-sized companies. And what is interesting here is that the progress or innovation, as we call it, in the area of engineering can only be accomplished if we factor in the human contribution and if we start really valuing it, and to try to replace them only partially, because the fully automated factory, the big dream of Industry 4.0, will be there at some point in the future, but we would have to integrate so much knowledge and experience from human beings that we would have to make huge progress to get there. But I would like to come back to one thing you mentioned. A couple of years ago, researchers found out that squirrels are not as intelligent as you would believe in order to remember the things you just mentioned. They hide their food within their territory that's been marked, and once winters come, they start searching somewhere. And that is actually an intelligent coincidence. So they do not really remember where they've hidden away their nuts. So thank you again for this beautiful example. And that's a really great result of biological research. So it's about human beings to think about how the way that squirrels hide their food can be optimized. No, not really. What do you think about honeybees, Mr. Landgraf? Well, honeybees are much more intelligent. And the decision whether a behavior can be called intelligent or not is very relative from a human point of view. For example, if I said that I find a location within a certain radius again after some time, then we'd say that's not too bad. But if honeybees were able to do that, would we say that they are intelligent? I don't know. There's always a dimension to intelligence that makes it necessary for us to measure their performance relating to a certain task. Well, and if I change the task and the point of view, then this again will influence our result. And I think that's a very complex task because it's so flexible and it's hard to reach the core aspect here. Well, but that only relates to the tasks you just mentioned. Let's consider an individual that can add different calculations or similar things, and we would get to the point where we said this person is not that intelligent. But if we try to use another benchmark, emotional intelligence, for example, then this person would not be intelligent. And that's why I do not really prefer just using AI. Let's use chess as an example. We have a very limited perspective in order to judge whether what's happening is good or bad. Let me add one thing. I am very much in favor of looking at different ways of being intelligent in different areas, but still we are researchers and scientists, and that's why we realize that different fields of research use the term intelligence. And you're only right when you point out that you as an engineer are not interested in the term itself. And Ms. Narciss, you might agree, because there are some similarities when it comes to using the term intelligence. And when we look at the Latin origin intelligere, then it seems that intelligence is somewhere in between when it comes to defining these tasks and the path towards solving the tasks, or somewhere in between thinking and reasoning about it and acting. But the fact that we are able to define something in between and not to react simply on impulse, then this is something that we observe in every area. The problem is the measurability. Let's say we define intelligence as intelligent behavior. So something about the behavior has to be smart or intelligent. Imagine I'm waving and a dog brings me something that I wanted it to bring. Is that intelligent? And what are the cognitive processes that I've used as a basis? When it comes to AI-based software, I can measure every single thing that happens within it. That's not true for human beings because we cannot analyze every single neuron. And I just assume that it doesn't really matter which description we use as a basis, because at the end of the day, this really depends on the person observing it and measuring it. You're right. I think we can agree that measurability is difficult. And I would love to hear a researcher's insight on what that means in terms of the human brain, because possibly we do not use the entire capacity of our human brain. However, I'm interested in hearing more about your honeybees, and you mentioned that you have some slides that you would like to show us. So maybe you could tell us a little bit more about what you learned in terms of how they reacted to robots. What about their brain activities, and were they affected by it? These are only 4 videos, and what you can see here, or rather, what I love about my job is that I can really show you what's happening. On the left-hand side, we see a guppy robot that is being followed by real guppies, and on the right-hand side we see honeybees and the robot that tries to copy the waggle dance of the bees and send them to a source of food that does not really exist. So these 2 examples are to show you that these robots try to show the natural enemies where the food source is, and we want to find out which signals they need to convey to the real bees. For example, how do the wings of the bee need to vibrate? How does the dance need to be performed for the natural bees to understand it? Or in which way does the robot guppy need to move so that the real guppies follow him? We have numerous questions, which I cannot mention today, but the computer analyzes the swarm intelligence through mathematic descriptions on how individuals adapt the way they move, and these mathematical descriptions are then used by the computer, even though we cannot really validate that within the real world. The robot makes this possible. Of course, we do not only build robots, we also analyze honeybees and their behavior. And in order to do that, we use AI. Unfortunately, the video does not work, but imagine the bees moving. And what we do is that we use AI in order to analyze the bees' IDs and their position, and to observe it over time to understand how they interact and what they do. For example, the Waggle dance of the bees, we're able to recognize that. For those of you who do not know about the dance, it is a way for bees to communicate with other bees and to tell them about the food source, how far away it is, in which direction they need to fly. And we can imitate this waggle dance by observing the way they move through AI, and we can use the AI to understand where the bee has found food and where the other bees are going to be directed towards. Of course, we also use applications derived from the bee's behavior. These cars actually interchange energy while driving. Bees actually can communicate. For example, if they've come back from foraging and one bee says, "I'm hungry," then the other bee gives the hungry bee some nectar so that this bee can continue working. And that's an interesting aspect we learned about from bees and tried to implement that. And possibly this might be interesting for electric cars in future. Another interesting aspect is related to neural networks. We train them. Train them so that they can recognize patterns, for example, dogs or monkeys. But if we want to use them for autonomous driving, or, for example, when it comes to diagnostics in medicine, so everything that could be a potential risk to human lives, then we need to understand that we do not fully understand how these neural networks work. And what we do is we try to explain the way these neural networks work. For example, if we have an input image, we try to find out which parts of the picture were especially important to the neural network to make its decision. Vincent, I think there's a question from our virtual audience. Good morning, everyone. Lutz has made a comment which I would like to pass on. The fact that Ms. Narciss raised that we pass on too many tasks to AI-based machines is similar to the development we observed in the 20th century in the terms of the Industrial Revolution. Human beings should rather focus on tasks in which it excels in terms of AI, or in which it is performs better than AI. So we should hand over certain tasks to AI instead of all of these tasks. Ms. Narciss, would you like to comment on that?
Ja, also das wurde jetzt als absurd abgetan, dass das Risiko bestehen.
It was said it was absurd that there was a risk, namely if we delegate too much to technology, that certain skills could wither Creative skills, for instance, have been mentioned. Here, still, creative things are very difficult to delegate to technical systems, even though there are first examples here. What human beings are particularly good at, namely to be creative, to be critical, and if there is a lot of information, a certain degree of certainty, so that a decision can be taken, is it a dog or a monkey? It has to be clear what is the most relevant information. This is the same for human beings. We are relatively good compared to machines if information is incomplete to still come to good conclusions. But there are limits. If you look at the work by Gerd Gigerensen, there is heuristics for how to deal with that, and we are relatively good at it. This will be a field which will stay with humans. However, certain skills, if they are not fostered and developed, they may not vanish, but be put on a back burner and become not so well developed anymore. I wouldn't call it absurd. At the moment, I deal a lot with engineers and electrical engineers, and this is important, or it's important to manage that tightrope walk. How do tasks change? By using equipment and technology, tasks change. What does that mean for people who work there? What kind of training do they need? But not all people in the world can be artists afterwards. The robustness of the system is the problem. If I become dependent on that, and the system will always be running, but what happens if the system fails and I don't have those skills anymore as a human being? So we have to think about that. Ms. Becker, the 19th century, as a cue. 1956, the notion of artificial intelligence was coined. What can you say about all this? When you have a look at humans, who are mentioned here time and again, human beings are the result of millions of years of evolution. There is language, social interaction, the development of mental skills. Over the last 5,000 years, they have dramatically developed. It's breathtaking, and that makes it extremely difficult to see human beings as a constant factor. It's the product of co-evolution on a planet where there are lots of collective organisms. This boundless hubris of people should be corrected. We should see ourselves as part of a system where there are lots of other organisms from whom we need to learn and learn how to think. And machines are part of that as well. This wonderful book by Lovelock, a short essay, the title is Novocene, so based on Anthropocene. He is enthusiastic about artificial intelligence, where sensors and actuators are fitted everywhere on the planet, managing to keep the planet so cool that we can survive. So we should combine the Anthropocene and the Novocene so that people have a chance to think as well, but we depend on other organisms thinking as well, so to speak, including whales in our oceans. Learning, continuous learning, those are your topics you look into. You look into techniques to improve learning. What is important knowledge? Knowledge will change. What are you working on? What are strategies for this education landscape? And that will affect families as well as universities. Answer. It has been said here, you said in the media, they say we don't use the full capacity of our brains, so a lot is lying fallow. This is what you told me on the telephone as well. When you have a look at neuroscientific findings, it's not a sign of intelligent behavior if there is a lot of metabolism. On the contrary, studies show if people are highly skilled, highly intelligent, and you can see that in new activities, those differences in intelligence. With imaging, you can see less activity is needed in the brain, which need to be active, compared to people who are little skilled and have little intelligence. To use a lot of your brain doesn't necessarily mean to behave in an intelligent way. We always have to separate the biological level from the construct level. We interpret intelligent behavior in a certain way. This means, for instance, in our head, there is a mental map. How do I get there? Are there one-way roads and streets I cannot take? Now about the question, what is important concerning skills human beings are good at and which we will need in the future to organize education, to induce learning success, to support learning success. This is the topic I focus on. What can we do machines cannot do? Critical thinking, for instance. But not just critical thinking, communicating, interacting, not just in a local way, but also in a global way and in a distributed way in this globalized world. Social skills come into play as well. Those are points which are extremely important nowadays. To be able to make decisions in an environment of uncertainty. And the question is, how can we achieve that? That presupposes that we develop something which are called 21st century skills, critical thinking, namely reflecting, knowing how to deal with uncertainty and interconnected information. There are lots of open questions at the moment, lots of open issues. Responsibility, for instance, attitudes to develop values, not be selfish, but to have in mind the common good, and to take a decision where I would say I wouldn't do it if I were on my own, if I were alone, but as I have responsibility for others, I take a decision in this way. This has to be introduced into education. There is a big discussion at the OECD. You have mentioned that I work on feedback strategies, and with feedback on tasks you have performed, you can trigger new processes. That is particularly important if somebody finds a task still difficult. If I don't want that person to become dependent on my technical feedback, for instance, I have to make sure that I involve that person in the feedback strategy. I ask the person, where do you think you've been successful? And then I wait for the person to answer. If you wanted to do it in a technical way, You needed a model. You need to measure how much of the task has been performed, and if there is a discrepancy between what is actually going on and what the person thought was going on, it's important to confirm you've been correct. Here there is still a problem. Have you got an idea how to improve matters? So I ask a question. I don't say, you've seen that it is wrong. I don't provide a solution. If I want somebody to further develop, I have to make sure that they think for themselves. If I see that that person doesn't have their own idea, I can support that person to make progress. In a next process, the following would be important. So the person can use new findings, but for that, the person needs the opportunity to get practice so that the person will be able to transfer that to a new task in the future. Those are the feedback strategies I've dealt with over 20 years. It's great that you say that. This is the logical consequence that we have AI, which, with every one of us, with teachers and learners, interacts, gives feedback on our own behavior, opinions, or experiences we've had. And this is what we try to do with our fish, with our guppies, our bees. What Mr. Becker does, where we try to understand that. How can hybrid networks existing or consisting of people, biological intelligence, and AI, your car, your mobile phone, or your fridge, they communicate with us. They modulate our behavior by giving us the opportunity for activities. They are part of the network, but what is the upshot? Will that improve our lives? Under which angle do we see it? It's not yet clear, but this is what the future holds. Namely, the awareness that we are already in this kind of network, that our mobile phone wants to have our data in order to be able to find out which actions, which information is the best. We will see that our mobile phones will get ever more varied. For our fish, we have the robot adjusted in such a way that it learns how to take fish best from A to B. The robot nudges and lures, goes in a circle. So what normal fish would not do, but our robot can do it. And our mobile phone will try the same. Of course, within an ethical and legal framework, but we will see that we will be nudged. How does a human being work? And I think that is very exciting from a scientific point of view, but also from an ethical point of view is maybe a bit of a moot point, maybe questionable. A word about ethics. It sounds very hopeful that the relationship between humans and machines can be observed in an ethical way. As a sociologist, I think ethics are overestimated and other things are underestimated. In the networks, it's not just people and machines, but states, organizations, churches, governments. I don't even want to mention China, which I've now done. China has developed a great feedback strategies, and they are in control of their population, save for small villages. Algorithm Watch, this organization watching over the application of algorithms. So it's important to have a close look at who is using which feedback strategies and who gives us what kind of feedback. If we don't start giving feedback to those who believe they can give us feedback, that would be not a good situation. This is highly intransparent. We don't know what Google's algorithms do and what happens with the data. I think we need to study that systematically. Otherwise, we don't have agency over it, no control over it, because the driver of the big companies is profit, among other things, Mr. Becker is saying. Experts say machines are stupid because they don't have awareness, but they have power, the power we provide them with. All those who are watching us online and the people in this hall will wonder, what does that mean? You as experts, our three experts with specific knowledge, what does that mean for learning, for our activities? Which kind of intelligence will be the main one, which we have to keep sight of? And what would you like to make us aware of, us in the audience? The remaining minutes, could you tell us what are your main future-oriented fields of research, and what advice would you give us? Normal people, students who say, I want to become a psychologist or a philosopher. What does that mean for me? What does Mr. Landgraf's research mean for me? What is on your agenda? What are the main points when we talk about actions and learning? My main point is that we don't see ourselves as independent individuals, but we are part of a network. We are interconnected. That is not new. We talk to each other, but very often when you see yourself, you perform a cut. This is nothing to do with me, and that is not true. It's us, and this is more than I plus you and you. This is my first point. And second point, in the development we are undergoing, there is a huge chance to interact with artificial intelligence. It's not yet intelligent, maybe artificial, but not yet intelligent. With AI, we have a chance to shape the society we want to live in. So the leap from the local to the global, from myself to society at large, and young people do that much better already than 40 years ago. I'm very proud of our young people, I'm proud of our youth, and I look forward to the future. During the climate crisis, young people have understood what this is all about. We make good use of networks to exchange opinions, to exchange information, but we should be aware of the fact that more interconnectedness may not necessarily be better, because we are the result of an evolution, of an optimization process which is going on, and we haven't optimized ourselves for a close-knit network. Apparently there is an optimum, and if there is more network and interconnectedness, it will be downhill again. So awareness of that is the second point I had wanted to make.
Ms. Narciss, what's your opinion? Well, you've already mentioned interconnectedness, and I would like to focus on an issue I already mentioned. If we take 21st century skills, then we need to realize that we have to improve these. For example, our ability to think critically, innovatively. What we need to improve and train are things that we that we receive through digital technologies and to regard it as a tool or an instrument, but not to rely on that 100%, but rather to question whether that is a reliable source, which kind of source is it, and I need to validate whether the information I get is really important. So we should always apply our own way of thinking and our own knowledge and to question it regularly. We can only generate this kind of information if we turn things around once at a time. And these highly complex processes of thinking are important, but we must not kid ourselves pretending that we do not need knowledge because we can Google it, which is wrong. If I want to be able to perform such activities, then I need to know about these things, and only then will I be able to understand the interconnectedness or understand which pieces are still missing, and then I'm able to interconnect that. So nobody can help us when it comes to building up our own basis of knowledge. We need to do that ourselves, and we need to be aware of the fact that we need to improve that regularly. So we should be aware of the fact that our knowledge is not set in stone, but rather develops further as we get more information and more insights. For example, take this pandemic. The knowledge we had about COVID-19 was constantly evolving and can even be corrected through new developments. So this should be something we take into consideration as well. So always remember, if you know something, then this is not everything, but the process is constantly evolving, and the things you know might be wrong or incomplete. Mr. Becker, when it comes to critical thinking, we have a great tradition. Think about Immanuel Kant, who wrote about 3 critical aspects. And from today's point of view, it is amazing to read his works and how he hoped that human beings would rely on their reasoning. He actually coined a term in German, Vernunfteln, so to reason about things endlessly without really thinking about it. So you realize when reading about Kant that he was hoping for human beings to reason about their environment and then apply this knowledge. So I am a great advocate of not only focusing on reasoning, thinking about critical aspects, but also understand that we need to be able to handle complex systems. The exhibition on AI really helps us in this respect. You can also visit another museum, go to a theater, etc. And this exhibition really is a great example. If you go to the exhibition and read about these numerous aspects, you need to make a choice. Which exhibits will I read more about and which do I have to ignore? So you need to pay attention how your body reacts to it, how your stomach reacts to it, how your fingertips react to it. Does it make you sweat? How does your body react to it? So you get the idea. So which pieces confuse me, irritate me, etc. So interpret the different competences we have as human beings as signals and understand how complex we are in order to see how we interact with our world. Our capability of using our reason is important as well, but at the same time, other parts of our body react to other aspects in our life, family, friends, and any other aspect. So what I want to say is that we should understand that everything that influences us is rather on a horizontal level and not in a bottom-up hierarchy. There's a questions from the audience. I know you were about to deliver your final words or concluding words, but I would like to mention a discrepancy, because what I realize when listening to your statements is that you're skeptical when it comes to the term intelligence. However, if you use the Google Ngram Viewer, a tool by Google that analyzes different texts saved by Google in order to understand how often a term was used at a certain point in time, and if you use this viewer in order to analyze the time we live in and the text archives, then I'm sure that the term intelligence is the most frequently used word. So how can you explain this huge gap then when different disciplines, sociology and other research disciplines are so skeptical about the term, but compared to that, in the public debate, intelligence, the term, is so frequently used. Obviously, the public debate really needs to talk about artificial intelligence, while professionals and researchers contradict that. How can you explain this gap in using the word? In my opinion, that is not a contradiction, but rather a very normal development. If we'd all agree on the term, then I think you wouldn't encounter it as often in the texts. Unfortunately, Ms. Ilmer is off mic, so I cannot understand what she's saying. I think it tells us something vital about our society, and at the same time, researchers and other professionals do not use it as often. A term that is being used as frequently as intelligence since the 1950s in our Western societies, then we need to infer that society really needs an answer to the solution of this problem, but there are no researchers that try to answer their questions. Well, we've just talked about that for 60 minutes. Research shares the fascination for AI, but with numerous different concepts and critical ways of observing this development. And your first reaction, I don't really care, is great proof that shows that you do care about it, because then you went on to explain how you didn't care about it, showing us that you actually cared. And I believe that researchers are rather, we're in the same situation with the audience, but we have, so to speak, different glasses on from a scientific point of view. I would like to ask a question. How can you use the analysis of such a frequency in order to infer different needs of society? I do not have an answer to your question, but the question is great. Thank you very much. I just assume that the more frequently a term is used, the more controversial and the more important is it, because you need to explain the frequency in some way, and that is why I assume that there's a great need in society to define the term intelligence, but you may be right that the correlation is entirely wrong. Well, you use one explanation for the frequency of the term intelligence, but maybe it is similar to fashion. At the end of the 1980s, 90s, this trendy word or term was very fashionable, and maybe we see the same development right now. Maybe this is rather a snowball effect. I do not know whether that really is in line with the demands in society. And I mean, the Engram viewer also takes scientific publications into consideration, which only goes to show that everybody is talking about it. And that's why I do not really see the contradiction here. But despite that, which term would be more suitable in a larger context to observe machine learning critically? Which term would you rather use than intelligence? So I think this is a suitable term which we should use in society, and that also means that it is abused in research for fundraising campaigns. And I know you know that you need to label it with a certain word. I think the next panel discussion should really include a researcher in German language, for example. But thank you very much for your input. We are in a society of knowledge and input. So thank you for discussing the term intelligence. And you already mentioned Kant. To put it into different words, or to sum it up, let's use the term intelligence, and maybe every one of you could sum it up by just saying one sentence, either about your research, the swarm intelligence. For example, I'm a bit overwhelmed and I do not feel that intelligent today, so I might not be able to do that. Intelligence. Who can benefit from it? I don't know. Philosophical way of ending your contribution. Thank you. Ms. Narciss, I'd love to use the opportunity to mention a new publication of Sternberg called Adaptive Intelligence. He is a scientist that focus on this construct from psychology and further develops it against the backdrop of current challenges. And I'm sure that will be a very interesting and insightful publication. Mr. Becker, I think intelligence is the ability to accept that some people take detours. Thank you very much for this interesting input. Thank you for your contributions when it comes to improving our own individual intelligence. Thank you very much. And at 1 p.m., the next panel will deal with artificial stupidity, failures and accidents due to AI. Thank you very much. I hope you enjoy the rest of your day and the exhibition. All the best. Thank you.